Hi everybody, Jamie Zachary here again. I've brought my friend Devon Robinson, who is an applications engineer here at Solex. Devon, thanks for joining me today.
No problem. Happy to be here.
Yeah, we're here today in Solex's lab in Calgary, Alberta, Canada, and we're going to talk a little bit about lab testing and, really, why do we lab test? Why is it important?
We lab test because there's a lot of things that we work with that are very difficult to define in a way that you could send in an email. Bulk solids, they vary tremendously. They can be really fine, very flowable. They can be, a little bit more sticky. Water can be involved. There's a lot of things that it's not a fluid where you can give me a viscosity and a couple other parameters and I could say, here's your size. We can get an idea, and sometimes just a picture or having something like this can give us a really good opportunity to, throw a sizing out there. But anything that we're going to actually sell, we need to have at least a reference or some past experience with it. And if we haven't, we really want to try to lab test it because, the flowability is so important in our units to make sure everything flows uniformly and reliably. And it's hard to guarantee you can do that just based on someone giving you, for example, a particle size. So practical testing is really the only way to be sure that it's going to flow properly.
Perfect. Now, how do we lab test? We're here in the lab today, but what are some examples?
So lab testing, we do a number of tests. We're going to do flow testing, as I mentioned, is probably the most important one. We test for thermal properties, which includes the specific heat capacity of the material, as well as the bulk thermal conductivity, which is different from the regular solid conductivity. So on an example is if we had steel ball bearings, I couldn't use the stainless steel or steel thermal conductivity for that material. We need to do a practical test and analyze how the effective material, including all the shapes and stuff of the particles, are counted in there so you get an effective conductivity. And that's something that our customers almost never have, so it's really important for us to test it. So we do things like the thermal properties, flowability I mentioned. We will check bulk density. The angle of repose of the product's a really simple one. It helps us size our inlet hopper so that we make sure that all the plates get covered and the hopper at the top's not oversized either. And then sometimes we dig into other things like the way that it responds to humidity, critical relative humidity is specifically the thing, and finding out something like for fertilizer, for example, at what humidity is it going to begin to absorb moisture from the air for some given temperature. So we can go pretty deep with certain things, and other times it's just a quick double check.
Yeah. Now, are there different levels of testing that will require different amount of samples that you'll need?
Certainly. We don't have a really formal, chart and say ABC, but we definitely do have times where, we might just need a couple liters of sample just to verify thermal properties. Maybe we're very confident in the flowability or we've done something similar, but the uncertainty is maybe in the specific heat capacity or something along those lines. Sometimes it's just a quick double check to flow test it. But a lot of times with the smaller stuff we do here, we can do a smaller sample, about a gallon is what we often ask for, and that covers us because we can also send that amount for shear cell testing, and that's to get something really formalized from a third party. But if we're doing our normal set of tests, we generally would ask for 2 5-gallon pails or 40 liters in total of the sample. That's going to allow us to do our flow testing, and while we're doing that, we can try different feeders and get a good idea of what's the right configuration from a feeder standpoint, and that gives us enough sample to do everything else here that we need to do for the particle size checks and the bulk density or anything else. And beyond that, sometimes there are other concerns that can't be addressed by room temperature testing, because everything we do here, for the most part, happens at room temperature. But we do have the ability to step that up, particularly in heating applications. But we can do an in-lab pilot with a much larger sample. We'll have times where we might get a super sack, a ton of product or so, and run a continuous representative pilot to mimic the conditions we expect to produce. And we can validate things like how much moisture did we actually drive off the product when we heated it to this temperature, or did it get greasy, or certain products we're worried they might soften at temperatures. Certain things like that, you do want to be able to do something a little bit more representative of process conditions. If it happens to be a heater, we can do those in the lab here a lot of the time. In cooling situations, we often have to go more to the on-site pilot. And same thing applies though, where it's a much bigger thing, and I think it all falls under the same umbrella.
Yeah. So sometimes as small as this, sometimes as big as a ton.
Yeah, exactly, right. It varies a lot. It comes down to, what the risks we think are and what our experience is with the product, and a lot of the times how the process differs from our experience, because it is oftentimes very process related.
So we've been doing this for a long time. Do we still test everything?
No, we've got a really good database of tests that we've done. We've also got a lot of projects out there that we know are working well. So we can lean on our experience a lot of times for more simple applications, typical products, things like sand, it's not a bad one. Fertilizer, there's plenty of grades of fertilizer that we don't need to test again. We've seen a lot of them, but there's an immense amount of variability within something like fertilizer. There's even to just an NPK fertilizer, there's a huge amount of different grades. Some are quite difficult and hygroscopic and they turn to mush, and others are really easy. But we have an immense amount of experience testing different types, and those are a lot of those situations where we say, hey, send this stuff in, let's do some humidity testing on it and just double check the thermal properties, but we don't need to flow test because it's just another NPK granule. We know it flows, at the spacing that we want. So that's some of those times where we tailor what we need for the specific application, because we don't need to be repeating the same tests. We've looked at a lot of our oil seeds and our fertilizers, and when we know we have history with it, we don't want to slow down the process unless there's some particular constraint where we need to look more closely than we had before.